Hello everyone. In this video I will be explaining about graphs of parent functions and transformations of parent functions. There are a lot of different functions out there. We're going to look at a lot of them, but it turns out many of them evolved from what are called parent functions, and parent functions are used to generate new functions. The meaning of parent function is very fundamental, very simplest form of the functions. We need to know every type of function so that we can solve the transformation questions. Okay, let's go through the functions that we studied so far. Linear functions. Linear functions are rising from left to right, it's a straight line, or falling down from left to right. The basic parent function is x, f of x equals x. Absolute value parent function, it's a v-shaped function. It's written inside an absolute value. And we can write this as a piecewise function that we studied in chapter 5, grade 11, in chapter 5, section 2. Square root function, this is a curly shape. It's square root of x and it's increasing from left to right, starting from the origin. And there is another function that you haven't seen yet. We haven't studied this function. This is called greatest integer function, and this function is constant for a while and then jumps. Between two numbers, the function is constant and then jumps. Again, constant jumps, constant jumps, and so on. This function goes infinitely up and down, having a constant part first and then jumps, another constant and then jumps. So these kind of functions are called a greatest integer function or step function. And quadratic function, this is a parabolic shape, opening up or opening down parabola. The basic parent function, the basic quadratic function is x squared. Another function, cubic one, the cubic one is x cubed. It's something like that. Rational function, or you learn this as inverse function. The basic inverse function is 1 over x. It has two parts like this, one in the first quadrant, the other one is in the third quadrant. Exponential parent function, it is rising from left to right slowly at first and then very fast, and it's approaching to x-axis. We have an asymptote. Similarly, in logarithmic parent function, this is inverse of exponential function. It's again rising from left to right, but the increase is fast at first and then slow. It's opposite of exponential function. Since they are the opposites, the asymptote will be changed to y-axis. Trigonometric parent functions, sine function and cosine functions are wavy shapes. This shape, this wavy figure goes on forever. The sine function is passing through the origin. The cosine function is passing through 1 on the y-axis. Tangent function is different than these sine and cosine functions. It is like cubic function, the repeating cubic function. We have this shape repeats infinitely from right to left. And there are asymptotes, vertical asymptotes. So after we talk about the basic types of functions, we will start transformations. We have to know every type of function and how they look like. Once you have one function, you can make a whole bunch of things by just shifting around. If we move around the coordinate plane, what we are doing is producing a transformation. Now we are going to talk about how to transform functions and types of transformations. Okay, let's see the rules. Let's remember the rules. We studied these before. Let's just remember them. If the original function is f of x, horizontal shift, and the c is a positive number, let's suppose, Horizontal shift to the right means f of x minus c. Horizontal shift c units to the left means f of x plus c. So going to the right, we will subtract c inside the function. Going to the left, we will add c inside the function. The horizontal shift changes the inside. On the other hand, vertical shift changes the outside. It doesn't affect the inside. We will add or subtract at the end of the function. Our original function is f of x. If we are going downward, then we will subtract c after f of c, after writing f of c at the end of f of c. Similarly, if you are going upward, then you are adding c outside of the function. This is going down, this is going up. Plus c means going up, minus c going down. Okay, we studied two types of reflection so far. So reflection around y-axis, x-axis means the sign of the function changes. If our function is looking up, our function will look down. If there is symmetry with respect to x-axis, we will flip this function around the x-axis, so we will change the sign of the function. On the other hand, if there is reflection around y-axis, let's suppose we have a function like this, and if the reflection is around y-axis, we will flip this function around y-axis. It will look to the left. While it was looking on the right at first, now it's looking to the left. In this case, the sign of inside will change. So the sign of x will change, not sign of the function. And reflection around origin, we have double reflection here. We have reflection around y and reflection around x, both double reflection. It is like this. If this is the original one, we will reflect this around x, reflect this around y, so this will be reflection around origin. We applied both reflections. So by knowing these rules, we can do the transformations. So let's start and see how do we translate. Okay, vertical translation. Let's say this is our original function. F of x equals x squared. If we move this 2 units up, it becomes x squared plus 2. If we move this 2 units down, it becomes x squared minus 2. The change is outside because the translation is vertical. On the other hand, this is x squared. If I move this to the right, the change is inside for horizontal translation. So I don't write x plus 2. I will write x minus 2. It is the opposite of vertical translation. We are going right, we are subtracting x minus 2 squared. When we are going left, we are adding the opposite, x plus 2 squared. So we just apply the rules. Alright, let's talk about reflection. Reflection around x-axis, if that's our function, x. When you flip it around x-axis, this is how it looks, and you have opposite of this function, so minus is in front of the function. But reflection around y, the direction of the function changes. It's looking on the other side, it's looking to the left now, and the sign will change inside. Alright, so reflection around origin, we have double reflection, both y and x, or the opposite x and y. In both cases, you have this function, so this is the image of reflection around origin. So we have the sign changes inside and outside both. So those are the simple examples. So let's take a look at some exercise and ministry exam questions. Okay, first example. Okay, exercises 22 to 27 in the book. We are given a bunch of functions. They're all absolute value function. This is the original function. According by using this original function, we will make the given translations. First, f of x plus 5. What does plus 5 mean? Is change inside or outside? We decide this first. The change is inside, so that means that's horizontal translation. In horizontal translation, that 5 plus 5 means we need to go 5 units to the left. So from starting this function, this vertex, you go 5 units to the left. 1, 2, 3, 4, 5. Here is my vertex. So this is what I have when I translate this red function 5 units to the left. So what do I get? I get D. Part B, f of x minus 5. So we need to, the change is outside. So minus 5 means go down. How many units? 5 units go down. From starting this vertex, go 5 units down. 1, 2, 3, 4, 5. So here I am. So I shift this given function f of x 5 units down. So I got B. And let's take a look at this. Here I have both double reflection x and y. Reflection around x and reflection around y. Let me clear these annotations first. Okay, this is our original function. So we reflect our original function around, let's say, y or x first, it doesn't matter. Let's do the reflection around x first and then do reflection around y. We have reflection around origin, so we need to apply both. Okay, reflection around y. How do you reflect it around y? So if a function is reflected around y, then they're equidistant from the y-axis. So how many units I am away from the y-axis? 1, 2, 3 units. So the image will be also 3 units away from the y-axis on the other side of y-axis. So 1, 2, 3. So my new function would be here. So first I reflect it around x. I made it upside down, and then I reflect it around y. In order to reflect it around y, since it's not in the origin, then we need to make sure that my image is equidistant from the origin. So this is 3 units to the right, so my image will be also must be 3 units away from the y-axis. So here I am, minus f of minus x is this, and minus 2 here represents the changes outside. It is vertical change, so we need to move 2 units to the down. So move your function 2 units down. So here I am. So this is my new function, which is C. Okay, so there are a lot of things going on here: reflection, translation, all together. Another one, minus, again we have reflection. What kind of reflection do we have here? Minus is outside. Let's take a look at the rules. If minus is outside, what kind of reflection we have? If minus is outside, we have reflection around x-axis. So let's reflect it around x-axis first. X-axis first. This was the original function. Let's reflect it around x. Let's make it upside down. So here is my function. I am not done. I still have translation. How many units? What does this negative 4 represent? The changes inside. That's horizontal change. So how many units? 4 units. To the where? Left or right? to the right. So slide your function 4 units to the right. 1, 2, 3, 4. So here I am. That's my new function, which is a. All right. Okay. Next one. We have in both inside and outside translations. Here I have +6, which means 6 units to the left. Here +2, which is outside change, vertical change, 2 units up. 6 units left, 2 units up from starting the given original function. 6 units left. 1, 2, 3, 4, 5, 6, and 2 units up. 1, 2. Here I am. So that's my new function, which is e. And finally, we will translate our function 1 unit to the where, to the right, and 3 units where, up. 1 unit right, 3 units up. 1 unit right, 1, 2, 3 units up. So that's my new function, g. Okay, like this. So this question covers pretty much everything about transformations, all vertical, horizontal, the reflection, so everything you can see in this question. Okay, let's take a look at some ministry questions and see how the questions come in Wazari. Okay, here I have a quadratic function, a parabola. So we should describe the transformation. So we have negative first, right? That's reflection around x-axis. The function is upside down. So in every option we have negative in front. And considering this is the parent function, passing through the origin and opening up, this is the transformed version. So how did this function transformed? Okay, here you see the vertex was in the origin first and it shifted to the left and up. So see, it moved 1 unit to the left, 1, 2 units up. It moved, the function moved 1 unit to the left and 2 units up. So this is what I am looking for. 1 unit to the left means +1, right? So I am looking for +1 inside. Horizontal changes about inside, so I am looking for +1 inside, not -1, not -1, either A or B. And +2 represents 2 units up, so +2. This is outside change. So outside of the function, I am looking for +2. +1 inside, +2 outside, negative in front because of the reflection. So that's my answer, option A. All right. This year's 2023 second attempt ministry question. Similar idea. This is the given original parent. This is not a parent function. This is just a given function, absolute value function. And by using this given function, we will make this translation. What is the translation? +2 is the inside. +2 is the inside. This is horizontal. So we must move 2 units to the left. +5 is the outside change. It's a vertical change. So move your function 5 units up. 2 units left, 5 units up. 2 units left, 5 units up. Okay, this is the vertex. Move your vertex 1, 2 units left, and 1, 2, 3, 4, 5 up. So here is my new vertex. So this is how our new function will look like. In which option do we have this? Our new vertex would be located at 1, 1, 1, 1. Here I am. C, option C. Finally, let's transform a piecewise parent function. So not parents, piecewise cannot be parents. So this is the given function. By taking this function, we will translate this one unit to the where. This is the inside change, horizontal translation, plus one inside means one unit to the left. So let's move your function for one unit to the left. What function? This function, this piecewise function. So every piece of this function will be moved one unit to the left. This -4 point at -4 will be moved one unit to the left. It will be here. -2 would be moved one unit to the left. The new point would be here. This point would be moved here one unit to the left. This is also one unit to the left. When you connect them, so here is your new function. This is my new function when I translate this function one unit to the left. In which option do we have this? This looks like option C.